start solving multi-step inequalities. It's really not that different from equations, but there's one kind of exception, one thing we have to look out for today. And that's where we're going to start doing an activity that will kind of discover what I like to call the glitch. So imagine you have an inequality 4 is greater than 1. Well, that's true. And I'm going to write it over here. By the way, this is page 212 in your textbook. And we're going to take this inequality, 4 on the left, 1 on the right, and little by little, we're going to multiply by, increasingly smaller numbers. So we start with a 4 times a 3, 12 on the left, and a 1 times a 3. And we have 12 on the left, 3 on the right, and the inequality is still a greater than. Not very exciting. If I now take that 3 to a 2, and I multiply 4 times 2, I get 8, and 1 times 2, I get 2, still going to be a greater than, because 8 is greater than 2. If I multiply that original equality by 1 on both sides, 4 times 1 will give me 4 on the left, and 1 times 1 will give me 1, and it's still greater than. You're starting to wonder, why are we doing this? When we take 4 times 0, I'm going to get 0 on the left, and 1 times 0 is going to give me 0 on the right, and something has just sort of changed, kind of like a tipping point. When I take 4 times negative 1, I'm going to get negative 4, and when I take 1 times negative 1, I'm going to get negative 1, and let's stop ourselves and think here. Negative 4 is smaller than negative 1. Remember that the negatives go in the opposite direction, and we have just seen the inequality flip, switch. 4 times negative 2 is negative 8. 1 times negative 2 is negative 2. And again, negative 8 is less than negative 2. 4 times negative 3 is negative 12. And 1 times negative 3 is negative 3. And again, we see that it's less than. So when we multiply this inequality by a negative number, we had to switch the inequality from a greater than to a less than so that it would be true. So today, as we are solving inequalities, we have to remember that this is sort of the one little weirdness surrounding inequalities. If we multiply, or by the way, divide, either side of the inequality by a negative number, we're going to have to switch the inequality sign. And I call it, here's a wigglefism, I call it the glitch. So when you multiply or divide both sides of the inequality by a negative number, it's kind of like a speed bump. You got to stop yourself and remember that the direction of the inequality is going to be switched. So as we go forward, solving our inequalities, we've just got to catch ourselves when this happens. It's easy to forget. So here's a simple inequality. It's actually a one-step inequality. So I'm going to treat it just like it was an equation unless I encounter that glitch idea. So the first thing I need to do here is what? I just have to separate both, subtract both sides by negative 1. Does that make the inequality switch? Nope, because I'm subtracting. So I get x is greater than or equal to negative 5. We talked about graphing that, so I'm going to put a open or close, which will it be? A closed dot at negative 5, and I need all numbers greater than negative 5. And that would be my graph. In a second, I'll review interval notation as well with some of the more interesting ones. That's how we solve an inequality. It's the same as an equation so far. Okay, so now here's a fraction. It's a one term greater than or equal to another term, so I can multiply both sides by the reciprocal in order to clear the fraction. I can do this in one step. So I'm going to multiply both sides by a negative 3 over 2. And when I multiply by a negative, I have to remember the glitch. I have to remember that that inequality has to switch from being greater than or equal to less than or equal. And if I take 2, these 2's basically cancel, or you would see negative 6 divided by 2, which is negative 3. So the mistake here would be to have a greater than. And I'll talk about how you can catch that in a minute, okay? So here I would put a solid point and all numbers less than -3, and that's how my graph would look. So here's kind of a simple two-step inequalities. Again, treating it like an equation. I'm going to start, be careful here. Sometimes people will make a mistake and they'll try to add 2 to both sides. This minus is the -2, that's his sign. This 2 is positive. So we should be subtracting 2 on both sides. This makes a 0 pair. Do not cut the arm off the number, people. This is a -2x, and 4 minus 2 is 2. And we would not switch the inequality because subtracting 2 doesn't do that. When I divide by the -2, however, I am going to switch that inequality, and I'll get x is less than or equal to -1. This is, I want to remind you, this is called a bounded solution in that it's bounded on the top. It goes on forever in the negative infinity direction, but it is sort of bounded up here. I just thought I'd use that term here. So solid at -1 and all the numbers less than. Okay, so let's get a little bit more interesting here. So the first thing I notice is that I have a distributive property, so I'm going to distribute. This is where, again, not distributing to the second piece, don't put a 1 here, right? 6 times n minus 6 times 1. Now I have a variable on both sides, so I decided to subtract 4n from both sides, making a 0 pair here. Again, I'm showing every step. I would have a 3 is greater than 2n minus 6. I'm not switching the inequality because subtracting does not do that. I now would add 6 to both sides. That doesn't flip the inequality. And finally, my last step is to divide by 2, which also does not flip the inequality. Now I'm just going to make a note here before we graph it and remind ourselves about interval notation. I want to make a note that if you had subtracted the 6n and gone the negative root here, you would have ended up having to flip the inequality. This whole thing kind of would be switched around. Okay, so just so you know that. If you pick the negative root, you have to oftentimes deal with the glitch. And that's why up to this point in time, I was trying to get you to stay positive because I knew this was coming. Now, when I go to graph this one, oftentimes people have trouble with the variable on the other side. Remember, you can flip this whole thing, or rather spin it would be a better word. N is less than 9/2. N is less than 4.5. So now we're going to have an open point to the left. Again, this is a bounded solution. And if we wanted to do our interval notation, we would have a parenthesis, negative infinity, comma, 9/2 or 4.5, parenthesis. I'm going to write some more on the next couple of slides just to remind you. So here's where you can kind of catch if you missed the glitch. Checking an inequality is not required, but it can help you feel confident about your answer. So you could check your solution with multiple points, but a quick check can be done just by using like one test point. So in this particular case, and I love the number 0, right? So if we go back, see how 0 is part of the solution. So 0 should work in the original inequality. So if I put 0 in here, I'll get 3 on the left. If I put 0 over here, I will get 6 times -1, and I end up with this inequality, this inequality right here. And since that's true, the solution checks. If you miss the glitch at any point and you check one number, it won't work. And oftentimes that helps you to catch and go, oh no, I forgot to flip the inequality. So I will never say check an inequality as part of the points, because you'd have to check an infinite number of points because there's an infinite number of solutions. But you kind of can do one just to test to make sure that everything's looking good. Okay, so let's talk about, our special cases. So everything's looking kind of complicated here. So I'm seeing a distributive property on the left, and I'm seeing the like terms on the right. So 2 times the 3x. Don't forget the 2 times the 2. On the other side, I'm going to combine the 8x and the negative 2x. They're same side, so we just bring them together. And right here, I notice that I don't have a choice with the variable on both sides. So when I take the one choice I have, which is to subtract 6x, again, the inequality is not going to flip, or switch, I should say. I end up with 4 is less than or equal to 3. And there is nowhere in the universe where 4 is less than or equal to 3. Is that resulting inequality true? And the answer is no. So what is your solution? Well, there isn't one. It's a no solution. And no matter what number you choose to put in and substitute for x in the original, there's no number that will work. You kind of can see it right here. You have 6x plus 4 being less than or equal to the same thing plus 3. That doesn't make sense. So this would be a no solution. No check, obviously, because you don't check inequalities, but there's no reason or no reason to check this. Nobody will work. So now let's take a look at this one. We got to be a little bit careful. I put this in on purpose so that we're thinking distributive property, because there's an invisible 1 in front of this parenthesis. So it's kind of like you're distributing a negative 1 to both places. So we're going to distribute, and in this case, you would have 5 minus 2 minus 3x. That's oftentimes people will put a plus here. Combining like terms would be 5 minus 2. And if you notice here for a second, if this was to commute, if we were to change the order here, we've got the identical thing on both sides. But let's say you didn't notice that, and you go with your one choice, which is to add 3x to both sides, to combine the variable on both sides. And when you do that, you end up with 3 is greater than or equal to 3. And is that resulting inequality true? It is. So this would be identity, or all numbers is another way, all real numbers you can see. So no matter what number you choose to substitute in for x at the start, everybody would work. Let me just comment, though, that, if this equals component wasn't here, we'd be looking at a no solution. Kind of interesting to think about. So let's just finish off today with an application problem that's going to, where do we use this stuff? So you have an 8-foot piece of wood to make a picture frame, and the frame will have the length that will be twice as long as the width. So you want this distance on the rectangle to be basically twice this one. So this would be W, and I'm going to call this 2W. So we're going to write an inequality, and the perimeter of the frame must be less than 8 feet. So the first thing is I'm going to let W equal the width in feet, right? In feet, yeah. So let's let W equal the width in feet. Now I'm going to write my equation, or rather my inequality, because I don't have to use up all the wood. So basically 2 lengths plus 2 widths has to be less than or equal to the 8. We've done these before, we would put equal, but you think about real world, you can have scrap wood left over. So it's really an inequality. Now I'm going to take out the L and put in the 2W. So 2 lengths plus 2 widths has to be less than or equal to 8, which would give me a total of 6 widths being less than or equal to 8. Divide both sides by 6, and the width has to be less than or equal to 4/3. 4/3 is like 16 inches long. If you multiply by 12, it would be 4 times 12 is 48, divided by 3 is 16 inches. So the width would be 16 inches, and the length would be 32 inches. And that, those dimensions, rather, would give you the most use of the 8 feet of wood. So in this particular case, unlike our equations, I should say, we don't have to check our answer, because you could have a width smaller than 16 and a length smaller and have more scrap, basically. So there are more answers than just this one, but this is your biggest. So today we talked about solving inequalities. It really isn't any different than equations, with one exception. It's the glitch is what I call it. And anytime you multiply or divide both sides of the inequality by a negative, you have to switch the inequality. It doesn't matter what number is on the other side of the inequality, whether it's negative or positive. You're just looking at the number that you're dividing or multiplying by. And if that number that you are dividing or multiplying by is a negative, that's the glitch, and you have to switch the inequality. Other than that, it's sort of the same, other than not having to do checks, formal checks as well. So I hope you have some good success with solving inequalities, and I also hope you have a wonderful day. I'll see you soon.